That's pretty darn high.
Why is that the case?
Not doing anything is not an option.
Is this a concern? Yes, it is.
Organizations are reevaluating their cloud strategies to maximize the advantages of cost and security.
Now that we've been in this transformation now for a few years and we've had some production experience running in the cloud, running Kubernetes, it's not surprising that organizations now are taking a serious look.
With so many concerned about the costs always ramping up inside of a cloud native development in general, especially in security, how can we reason about these costs and what's the impact of doing nothing?
We have to think about how are we getting the best compute? What are the best cloud networking services? Should we have one platform for needs like identity, or are we going to use many different? All of these are questions that, of course, bring up concerns around cost and also security.
Cloud providers only have one security tier for all their customers. So when you open an account, say with AWS or Google, you get the same comprehensive security features as their most security conscious customers. So in my opinion, postponing your move to the cloud, if that's a potential outcome, will likely not improve your overall security posture. Also, the software you build and use decays over time. It becomes exposed to exploits which were not present before. So doing nothing progressively leads to less secure software.
From my standpoint, you're getting a number of teams that are building Kubernetes that aren't always aligned with the central infrastructure and IT and security teams. And so if you've got platform teams out there spinning up to build Kubernetes environments and the security teams don't really have visibility or access to that, you can't build a picture of where you stand, and you don't understand how you're going to be able to respond to issues if and when they start to occur. So first and foremost, you're likely to have a lack of visibility, but if you don't have visibility, then you also likely don't have control over all of those Kubernetes clusters and instances. So if you don't have the ability to manage and apply changes and apply those corporate policies and that governance that you have in place, how can you be expected to protect those environments? And this is very much, in my opinion, a example of shadow IT. So this is cloud native teams going out, creating this software and building these clusters that enable this really fast development, because they can use open source software that they've downloaded from GitHub, but they're often doing that at the behest of security. So they're not doing it either with security involved, or they're maybe not so sure about the security implications of what they're bringing into the organization. So how can you, as a security expert, ensure that at the worst case, those developers or platform teams aren't letting the fox into the chicken coop at worst, or at best, how do you know you've not got machines that are running that aren't applying all of the corporate governance and control that you need to apply to either appeal to regulation or just ensure that you're running your business in a safe manner? I think there are other impacts as well. I think that you're seeing a lot of developer teams spinning up secret stores, and more often than not, they're not always managed or controlled that well. So you have the potential of leaked secret sprawl, and so on. So that's an issue that we're starting to see a number of InfoSec teams try to respond to. And I think what's going to be really important with this going forward is that security teams really lean in to development practices and try to, it's a little bit of a buzzword, but shift left and try to build security practices into the way these developers are starting to deploy code. So that's what I think might be some of the issues of doing nothing, and one of the ways that you can try and respond to that.
If you sort of paid a little bit of attention to operating at scale, lots and lots of containers, highly ephemeral. Containers are deployed, containers are destroyed. You have a pipeline that is continuously delivering. All of these essentially also has a huge security impact. So which means you're not looking at purely from, I need to secure that one single endpoint. You're looking at ensuring that every aspect of this architecture is secure. Those containers, do they have any vulnerabilities? Have they been patched? Are those container images that are running in those container or in that pod, are they signed? How do I ensure that nobody runs an unauthorized code within that container? So I want to ensure that it is signed. So there is a security aspect to it. How do I ensure that when two of these workloads are talking to each other, they talk to each other by using mutual authentication, which means each of them needs to be issued an identity that it is owned by that workload. And we don't want to issue an identity that lasts for a year or 90 days or 180 days for that workload, which may not even run for a few hours. So those identities need to be issued just in time for that workload to be able to do that. So not doing anything is not an option. So you have to essentially ensure that each of these aspects of the workloads are secured. They provide the right kind of visibility. They ensure that every single aspect of the applications are secure. We hear a lot about organizations talking about, oh, we are adopting a zero trust architecture and zero trust networking. And what does it mean? It starts with saying every line of communication should be encrypted. It is TLS everywhere. And what does it mean? It's not just the edge that needs to be protected. It's every aspect of the data flow that needs to have an identity. And each of these identities should be used as a way to authenticate to another workload, and depending on the authentication, also ensure that whether this workload is authorized to talk to it. So there's all aspects of security, right from the ensuring that there is an identity that is issued. These identities are used for authentication. These authentication mechanisms can be further leveraged to ensure that there is an authorization model in place. All of these are governed by policies, either centrally or locally at every cluster level for each workload. And finally, having a very comprehensive observability that allows security practitioners and the platform engineers to ensure that they can take the right kind of actions before something goes wrong.
Every cloud provider can manage machine identities in one way or the other. You've got different secrets managers, and in Kubernetes and other environments, different ways of managing machine identities. That's brought many organizations to say, wow, how do we do that more consistently? Which of course then would bring cost benefits, but also brings the opportunity to reduce risk and operate with more speed. So it's absolutely organizations from now into the future are going to be even taking a closer look how in their cloud strategy they maximize cost and security. And we see that more and more organizations looking to use control planes, trying to optimize around bringing consistency, areas like machine identity.
We need to learn more about the biggest threats and challenges impacting security and IT leaders today. If you want to know more, check out Venafi's full report on the state of cloud native security. Thank you very much.